Okay, so today we're going to have a look at the PFS154 candle project, and I'm going to start actually by building a little bit of a test bed so I can test each of these channels and scenarios out separately. So I've just got my PFS154 chips there out of the tube, and then I'm going to put four DIP 8 adapters down on the breadboard, as well as these little 1206 LED adapters that I use just when I'm doing projects like this, so I can just line up all of those LEDs. So I'm using the four so that I can show one channel PWM and then two channel PWM with the channels pulsing together, and then three channel PWM with the channels pulsing together, and then the last one there on the right hand side will be the three channel PWM, but each of those channels will be controlled independently using a randomizer, and that's what provides that sort of that candle approach that we've seen in a previous blog. So I just thought it was important to make the test bed up, and then I was just swapping the PFS154 in and out of the programmer and onto this test bed so that I could do all of those little variables, test them, make sure everything was running fine. So yeah, so that's it. So this is just showing how I put that together. There you can see the chips have been soldered onto the adapters, just been tacked with one corner, and now I'm just doing the other legs, and then I've also just tacked on the LEDs, and then I go and just do the other sides of that as well. So what we're left with finally is this lot of LEDs. I'm just going through the testing here, which was interesting because I thought I'd pulled out all yellow LEDs, but there's a green one. So actually, my OCD says go and change that, so I did. But yeah, they're all yellow. I guess because it's the candle that I'm trying to simulate. So I'm just going through and test all those LEDs. There's nothing worse as I found in the past when you set this up. There's the green one, to have a problem with the LED rather than the code itself. So there's the one channel pulsating gently. There's the two channel version, and then moving along to the three channel version, all pulsing together. And then finally on the end there we've got our candly version. So now we just have to see how is all that programmed. Here we are in a directory which contains just two files. We have the main code to produce a single PWM channel on our PFS154 and a make file. Just having a quick look at the make file. It just shows that we are targeting the PFS154. It's got a few other options, and we'll be using this one here, which is make program, which calls the easy PDK programmer with the following options, and it'll be writing the hex file to the actual chip just after it's programmed, just after it's compiled. If we have a look at the code itself, we have the includes which are required. We have the fact that we're looking at PA4 for our output, because we'll need to, over here we say, okay, we need to set that as an output itself. So PA4 is pin number 6 here, so a little confusing, but that's how that works. So we set that as an output. We've then got our initial conditions for our PWM, which is the minimums and the maximums. And then here we've got, this is the code that I had to spend a bit of time getting. So this actually is the register, and I'll put it up here behind. So this is the PWM G1 control register. Just going through it, here we've got the 7th bit, and that one actually enables the PWM. The 5th bit is to inverse the polarity of the PWM. You can play with that yourself. You've got then these two bits here, which tells you that the PWM needs to be outputted on PA4, and then you've got this final bit here which says that the clock that we're using, the clock source, is the IHRC. And then all that happens is it just simply fades up and fades down by just writing fade values to PWMG1, DTL, and DTH. Okay, so there's these registers here, and that's it. There's a bit of startup code which calibrates the clock, but that's it. So what I'm going to do is I'm just going to make program and see what happens. So what we're looking at is all of the coding being done there using the SDCC compiler, and we end up with 232 bytes and 116 words, and then it calibrates the IC after writing it, the hex file. Have a look at that directory now, and you can see that there's a build. Let's have a look at that. LSLA build. Okay, so there's an assembly file which I'll be certainly having a look at when I'm trying to find out more about how to move from C to assembler with this device. And there's also an output directory, and you can see here there's your 232 bytes. There's your hex file which is written to the actual chip itself. So that is the one channel PWM done. Okay, so here we are in a directory which contains also a main file and a make file. The make file is the same as what we've seen before, but this is for 2 channels PWM. So let's have a look at what the difference is. And you can see we've defined 2 LEDs now, and we've set them both to output. And then we've got this duplication of these registers here. So we've got PWMG1, which was seen before, and PWMG0. So that's the second one, and they're basically set up the same. So you've got this code here, which we've seen sets it up for one of the pins, and this sets up for another one of the pins, which if you go to the blog, you'll see that it's a little bit tricky how that works. But if you go to the blog, it's probably a little clearer from the explanation on the data sheet about what's going on. And then your fade in and your fade out is practically the same as the last one, except that you're fading in on both the first PWM channel and the second PWM channel for the high and low values. So let's have a look at how that works out. So we can do make program, and there it is, writing and calibrating. At this time we've got 276 bytes, so still well short of the 2 kilobytes of programming space that this chip has. And that's it for 2 channels. Here's a directory for 3 channels fading in unison. So again, a make file, and then you've got your main C file. We'll have a look at that main C file, and this will be fairly familiar. So now we've got our 3 LEDs outputting, and we've got our PWM1, which we've seen before, our PWM2, which we've seen 0, which we've seen before, and our PWM2. So that's our 3 channels. Apart from that, the commands are exactly the same. So this guy here you can see repeated in all of those. And again, I encourage you to go to the blog to see what these bits are doing to set up those PWM channels on those pins. And here's our fade in, and here we have our PWM1, our PWM0, and our PWM2. So let's have a look at that compiled. So we'll just do make program again, and there it is, writing to the chip, and this time it's 308 bytes. So yeah, still plenty of space, and then the calibration occurs after that. So that's our 3 PWM channels pulsating in unison. Here's the directory which contains the code required for 3 channels, but this time not pulsating together but actually randomly. So this is the actual candle code, and it's been ported across more or less from the A-Tiny13 version. So looking at this, we've just got an extra include file here because we're dealing with booleans. There's your 3 definitions for your LEDs. There's a random seed for the LFSR, random number generator. There's a lot of variables here to keep track of, where the slow PWM channel is, where the medium PWM channel is, where the fast PWM channel is. I've got some arrays here that set up the initial conditions for those, so these numbers are worth playing with, I should say, if you wanted to see what's going on with those, the slow, medium, and the fast channels. There's the booleans, which just sets whether are we going up or not. If we're not, then clearly we're going down, so they just keep track of that. Yeah, this is interesting. I had to create my delay routine because I actually use the random number generator to also generate a random delay, and delay is not too happy either on the AVR side or on the Padauk side to be dealing with a number that's generated on the fly. So what I do is just I go into delay this by 1 second, but I do it however many times that the randomizer tells me to, so it gets around that. So that's why it's called my delay. Here is my LFSR routine, which is pretty straightforward. Then I've got routines that get a new slow number, get a new medium number, and get a new fast number for my PWM. My main program looks very similar to what we've seen before, in that all we do is once we've actually got those numbers, we just push them out to the PWM channels, and then all it does is it ramps up the slow, ramps up the medium, and ramps up the fast, and then ramps down for all of them as well if that boolean changes. So that code is on the blog, and you feel free to play with some of those numbers. It's pretty interesting to see how you can actually affect those channels using those, like for instance, having a bit of a play with the timing of the ramping up and ramping down, and also these initial conditions about where these ramps start and finish. So yeah, that's pretty much the circuit working for this week, and the next thing to do, I guess, with this Padauk is to put it into a device which maybe uses some solar power to gather that energy during the day, and then pump it out as a fake candle at night. See you next time.